So we're gonna talk about logarithmic differentiation and we're gonna solve some problems. We are Valeria Gomez, Daniel Aldrete, and Osvaldo.
Is y is equal to x to the e to the x to the 2. So first of all, we're gonna get from both sides the natural log of them, because that's like the derivative of them. And so we're gonna get natural log of y, natural log of the function. Then we're gonna get the exponent out, and we're gonna leave like the same function with the natural log, and this side stays the same. Then we're gonna make product rule, and in the left side first we're gonna get like the derivative of natural log of y, which is 1 over y times y prime. And on this side we're gonna make the product rule. We're gonna have the normal v, and then the derivative of u, which is 2 times x to the e to the x to the 2. And then we're gonna sum the natural u and the derivative of ln and the function, which is 1 over x. Here, what we're gonna do is just multiply the product rule, and we're gonna sum it with this multiplication too, and the left side stays the same. Then what we're gonna do is we need this y over the other side, so for us to only have y prime over the left side. So what we're gonna do is we're gonna get this y to the other side by multiplying. So we're gonna have the y2, and all this function stays the same as we had right over it. And then what we're gonna do is that the y can stay as a y, so we're gonna get the y as the function we started with. So we're gonna get the y to be x to the e to the x to the 2 to multiply with the thing we already had. And at last, what we're gonna do is that this function is like the common factor of all the function. So we're gonna get it out of parentheses, and inside the parentheses we're gonna have the function we had by the product rule, but now we're gonna have it like the common factor thanks to the function of x to the e to the x to the 2, and that's our y prime.
Okay guys, so we're gonna solve this problem with logarithmic differentiation, which is y equal tan x to the x. So first what we're gonna do is we're gonna get the natural logs on both sides. So we have natural log of y and equals x, natural log of tan x. We do this to get this x here because we don't want it here, so we need it here to solve the problem. So then we derivate natural log of y with 1 over y times y prime equals 1, because we do product rule here, 1 times natural log of tan x plus the derivative of the parentheses, which is 1 over tan x times sec square x times x, and then we're gonna multiply all the expression by y to eliminate things we don't need. So this gets eliminated, and so we have only y prime, and that's equal to y because 1 times y is y, and the expression as we have it. Then we change this y to the real expression, and we get this, and that's how you solve the problem.
This next problem is a rather long one. There are lots of steps in order to solve it, but if you do them correctly, it is not that difficult. First, you need to order the first equation, which is this one, using the quotient rule. When you have ordered accordingly, you next need to start differentiating each, is starting from one side and then passing to the other one, so that it is easier. First, you need to use the product rule in the left side. We're going to start with the left side. You use the product rule in order to start solving the left side. Here it is. As you can see, it is I separated accordingly using the product rule. Next, in this part, you need to solve it using the chain rule. Here it is, all set accordingly. Now you just differentiate, and after you have differentiated and multiplied by this 1/3, you are left with this. Next, we're going to solve the right part of the parentheses. So you need to use the chain rule in order to solve this part. So after you have solved it, you're left with this, and you need to differentiate. Now you are left with this, and you need to add it up with this. So what you do is you multiply this part times 3 over 3. So you just multiply, add them up, and you're left with this big division or fraction. Then you just multiply this by this, and you're left with this bigger fraction. And we multiply all of the equation by 3 over 3, and you are left, and well, you after that you simplify, and you are left with this bigger but simpler equation. Now we are going to start solving the right part of the equation, the negative part, this part. So now you start by applying the chain rule to this small part. Here it is. You apply the chain rule, you differentiate it, and you are left with this. And that's the final part of the right section. So now, using the negative exponent rule, we go back to this small bit which has a negative 2/3 as an exponent. So using this rule, we are left with this. So the exponent now is now positive. So you just simply pass this bit down here, and that's your final answer.